Hello student, welcome to the video lecture of CAD. Today we will discuss the surface modeling. We know the different types of the surface modeling are. First one is the analytical surface entities, and in this the plane surface is there, ruled surface, surface of revolution and tabulated cylinder. The second type of the surface modeling is synthetic surface entities. In that the first one is the Bezier surface, then B-spline surface, cone patch, fillet surface and offset surface. So we'll start from the plane surface. So as the name indicates, it looks like the plane. This surface can be formed by using the three different coincident points. Suppose this is the first point, maybe P0. This is the second point, P1, and this is the third point, that is P2. If the surface is passing through three different points, then we'll get the plane surface. Okay, so different properties, or we can say the different instruction regarding the plane surface may be: it is the simplest surface, second, it is passing through three non-coincident point. The use of this surface is to find the cross-sectional views of cutted part. Okay, suppose this is the one object, suppose it is the cylinder, and if it is cut by this plane surface, so we'll get the cross-sectional view of the cylinder. Okay, so this is the use of the plane surface. This is the simplest form of the surface. It requires the three different non-coincident points, and the application is to find the cross-sectional views of the cutted part. So this is the x-axis, y-axis and z-axis. This is the surface. We have to find the parametric equation of the plane surface. Parametric equation means, you know, the student, parametric equation means to find the coordinate of the point on the surface. Okay, so let this may be any point, this point P be the any point on the surface, may have the coordinate u and v. Okay, so all of you know the distance of the points P0 from the origin in vector form is vector P0 bar, and P1 is P1 bar, and distance P2 is distance of point P2 from the origin is P2 bar. In the same way, the distance of point P from the origin is P bar. Okay, so from figure we can say from the figure P1 is equal to P0 plus U, P0 plus VU, where U is the parameter in x direction, and in the same way V is the parameter in y direction. Okay, so therefore U is equal to P1 minus P0. This is for the point P1. In the same way, P2 is equal to P0 plus V. Therefore, V is equal to P2 minus P0. So point P will be P0 plus U P1 minus P0 plus V P2 minus P0. So this is the parametric representation of the point P with the coordinate U and V. Okay, so normal vector for the point P n can be found. Normal vector n of point P can be found by using the surface normal vector can be found n in the form of uv is equal to p1 minus p0 into p2 minus p0 divided by p1 minus p0 into p2 minus p0, and u and v is in between 0 to 1. U is in between 0 to 1 as well as V is in between 0 to 1. These are the parameters. These are the parameters.